Welcome to everyone to the webinar MotionCode and new possibilities for free programmable motors. I'm happy to welcome all of you. First, I want to give you the information that we will record this webinar so that you also can watch it later on. And so then I will take the next half an hour and give you an overview what MotionCode is, what possibility it offers to you, and where also the way could go. As also a side note, if you have any question, feel free to place them in the chat so I can answer them at the end of the webinar, or feel free to have discussions in the end of the webinar session. Some short words to me and who I am. So I'm Markus Weishaar. I'm responsible here at Dunkermotoren for the topics industrial Internet of Things and also service, where the motion code programming and customer applications belongs to. So, and what are the topics which are important for me, where I stand for? So it's on one hand digitization, it's software, also automation, where I have worked a lot of my business life, and it's also just do it and let's do all these new solution topics. Then, yeah, I think a picture, I believe nearly every one of you knows this, how the world looks today. There are motors on the field level that are connected to a PLC over field buses like CANopen or Profibus, or over industrial Ethernets like Profinet, EtherCAT, or Ethernet IP. In some cases, the PLC is communicating with an ERP system like SAP or manufacturing execution systems. And in really rare cases, there is a connectivity to some clouds or some higher systems. And also, if you want to maintain and have an idea what's going on the field level, it's a little difficult. You need on both sides a technician, the right software. You have to go with one computer on the other. You need the right connectivity tools, so it's not that easy. And there we have solutions with IoT. If you are more interested in this section, feel also free to rewatch our last webinar on YouTube. But also, if we have a closer look to the motors and the programming and the PLC and the motors, there are also some, I wouldn't say disadvantages, but not that nice behavior in this situation. That is, everything must be implemented in the PLC with all the consequences. So if you want to build a modular machine, you always have this central code which you have to modify all the time, and adding new modules or software parts, removing some, checking all the interfaces, and that makes a lot of integration work. And so you have a high configuration effort for module machines because you have to test the code all the time. And that's some troubles where we see could MotionCode bring a benefit. So first of all, the step to MotionCode. So why MotionCode and what it is in a general way. So it gives you the possibility to program in service-oriented architectures. So have the code closed on the motor, or code on the motor for a module of different motors, and then just interacting with different other parts over service interfaces, over APIs, so that you don't have to worry about the code on the one motor if you change the code on another motor. So it's really bringing this service-oriented architecture behavior down to motors, down to the automation level. It also gives you the possibility for a decentralized software design. So you have, for example, a machine that is spread over some meters, that is spread over a whole factory. So you can program more locally, directly where the action has to be performed, and you don't have to bring everything in a central logic or back to a central logic. And also based on the both statements, you can build modular software design for your machines with closed functionalities and with service interfaces to interact between the different modules. As another thing, it's not always programming a whole machine or a whole device. In some cases, motion code also can be used to extend functionalities of smart motors, to adding some analyzers, to adding some diagnostics. You will hear some examples later on. And as a last step to answer the question why motion code, because it is easy programmable in C, means nearly everyone who is in programmable near studies learns C as a basic language. So it's an easy entry to start programming. Why we believe that this service-oriented architectures and decentralized software design and all that stuff is important. We see, I think we see it from other areas, for example, AWS, where Jeff Bezos forced his whole company to program just in that way. And I think that's the key part which makes AWS to that big player it is now. And it's also more and more coming in different areas for software design. That's the reason why we also set in this direction. So now we have clarified what is motion code basically, and then I want to start how it can extend a smart motor. And there I want to start with the quote that field devices become more and more intelligent and can take over more and more tasks from the layers above. So means from the control level, from the process level. So not in all cases there is a PLC needed, or a PLC controls just the process level, and the real-time logic is directly on the motor, on the devices, so that they react on their input parameters. If we are talking about a smart motor, what does we understand out of a smart motor? We see you see one on the left side, and there we see the DC drive and all the electronics is directly integrated in the motor. So there is nothing else needed to run the motor, just the motor itself. Also, it brings the whole connectivity with it, that it can interact with other parts of the systems. That's field buses like CAN Open, or industrial Ethernets like Profinet, Ethernet IP, and EtherCAT. It also has the possibility to interact with safety systems in that way that safety functionalities like safe log off is directly integrated in the motor. And also that this motor is free programmable in C, so that the logic who controls the motor can be directly programmed on the motor, and that is our motion code feature. I've primarily told motion code can extend the motor functionalities, but what can this be? What are these different functionalities? So for one example, it can be an automatic change of the configuration or the behavior based on input parameters coming over the bus system or over digital inputs. So for example, switching from a speed mode where I just control the speed to positioning mode, depending on the position where the motor is, for example, or on another point, as mentioned, react on digital inputs. I reach the sensor, then performing this action on this motor and program this directly local on the motor where the action is required. Another point is diagnostics. So for example, the motion is controlled still by a PLC. The commands come from there, but I want to have some additional diagnostic on the motor. For example, temperature, supervision of temperature, of currents, and just have an idea what's going on, some cycle counters that can be programmed directly on the motor, downloaded there, and so place this on every motor, he delivers the information you want to. You also can work with messaging. If you have the diagnostics, then send some messages out of the motor when some conditions, some thresholds are reached. And so you more or less come to a point where you on a basic condition monitoring implementation on the motor, So you don't have to think in the PLC how to program it, how to combine the values. You directly can do it on the motor, and so every motor where you download this motion code has the same behavior, and you can work with this data in different systems. For example, in an edge system, in a PLC, or in an MES system, in a maintenance system, you can use this data and you don't have to do all the logic in a PLC. So that's one part where motion code could be a helpful tool, where it can be useful for you. The another story which I already have started to introduce are this decentral and modular topology. So thinking automation a little bit different. So and here our quote is, there is no central intelligence necessary. Mechatronic modules enable a plug-and-play and service-oriented construction kit for machines. So what do I mean with this? So it's a placative statement. And of course, in most cases, there will be central intelligence, but this will not perform that much as it performs now. So it's more or less reliable or accountable for providing some process data, but the real action on the machine, this is really done in the field devices itself. And if you combine the devices to modules, then you can also combine these modules to full machines. I will give some examples. I have mentioned thinking in modules can be helpful. And the module, in our understanding, is the combination of all motors that mechanically belong to one functionality. For example, an unwinder which has a brake arm, the unwinder itself. So combine these two motors to one module, program this software directly on the motors, and link all sensors that is needed for this functionality directly on or onto motors. So that means you don't have to bring the wiring through the whole machine. You can react directly there where the action happens. And if you, for another customer application, need an unwinder with two brake arms, no problem. Taking out this module, building in the other module with three motors, and the needed logic is directly inside this module. And so you have a building kit for building your machine like out of Lego, removing something, adding some other functionality, and you don't have to interact with the code and always have to test the big PLC code and all the relationships there. So as I mentioned, all sensors connected directly to the motor, PLC logic directly programmed on the motors, and as I introduced before, doing the exchange of information between the modules with standardized service interfaces with APIs, and so design the machine in a software-oriented architecture. And if we go a step further, so that was one module. Of course, that's interesting, but I think more interesting it starts to get if there are more motors combined to a module and more modules to a machine. If you, like here, can see on the left side, if you, for example, exchange the wheel in the middle with its 5 motors, remove module 2, then bringing in just an overhead chain, which you have programmed with 2 motors, plug in this module, maybe it's module 4, and then interact with the other interfaces. And so you have changed the functionality of the machine, but not have to modify all the other modules. And so there, from our opinion, we come to real scalable design, because everything is not just electromechanical, it's electromechanical and software, everything combined, and you can mix and build your machines out of modules. So you come to a flexible and easy solution and can offer your customers a much higher variancy, because you don't have to manage a full PLC code for each variant, or you don't have to modify it all the time for each variant. As well, I think as another benefit in this area, of course, we have to talk about cost savings, because you have less components in total. You have less cabling to do, because the needed cabling can be done more locally, directly on the motors, on the modules, and then it's more or less a plug and play of the modules. And I think one really important topic is that if you have less materials, less part numbers, you have less material administration costs, like master data in the ERP systems and all that points. But now we have talked a lot what MotionCode can be do, and where MotionCode can be used, but who can benefit from MotionCode? Who do we address with this? So on the one side, we really address customers that want to realize an application but don't have own programmers. There we also offer the programming of MotionCode with our programming team. So you give us the requirements, you tell us which code is needed, and then you can ordering the programming as a service from us. So you're getting the motors and the code in one package. On the other hand, of course, we can't support everyone. So of course, we really address the customers that want to program by themselves, that want to use the MotionCode environment as a programming environment to realize their applications. And there we help with our knowledge to the motors to give them the right support, that they can use the motors in the right manner and do the programming. So what's needed to use MotionCode? I think that's also important to question, are there high barriers or not? I would say they are really, really low. So we have an Dunkermotoren BG motor is needed, the Move or the Pro series. Of course, you have to perform the code somewhere, you want to program this. You need a little bit parameter knowledge about our motors, so that you know which parameters you have, what do they act. But here we also have the knowledge base that supports you here in this point quite well. Here, as a short side note from my own experience, when I started here at Dunkermotoren, I had no knowledge about the motors, but within 1 week I was able to write bigger codes and had a quite good understanding what our parameters do. So also this is a quite easy step. Also, you need our IDE based on Eclipse to program. Of course, you need a program environment. You need 700 megabyte of disk space, Java, Windows, and some programming knowledge in C. But I think everyone who is programming is nearly able to program in C, or also have a close link to C. And you see this is if I already mentioned Windows, there are really less requirements needed to start with MotionCode. What is in the actual package? So what do we have? We offer our development environment to develop the needed code to perform on the motors. We have our libraries to interact with the motors, with all the motion commands. And I think we already have one question out of the chat from Maximilian. And here we have the question, how do we get the MotionCode to the upgrade, to the motor? Therefore, we have a tool with a close lookalike like the Drive Assistant. With that one, we can download the MotionCode easily to the motor. I hope that answers the question. Otherwise, we can discuss it as well later on. Also in the package are some sample programs to give you an idea how the programming is done. We have a user manual and a quick start guide in the package where you can read up some tips and tricks and some first walkthroughs to introduce you the code. And as well in this early phase, we're also offering for every interested customer that want to program a MotionCode 1 day of training to make the entry as easy as possible. And you see all this package is available from now and is so ready to use. So if you're interested, just feel free to contact us later on to also jump in. To give you a short idea how MotionCode does looks alike. So this is the MotionCode in environment. This is, I think it's a common console or a common programming environment, as most of programmers know. On the left side, you have the project configuration. On the right side, you have the function libraries. In the bottom, a console. At the top, just a menu bar, and in the middle, the programming window. So no rocket science, just common as used. Here at this code snippet, I just want to go to the middle line with this drive interface. There we see this write and read command. There we can read and write, or read values out of the motor, write something down. Here we are doing it with device command, and we write a free in it. So far, so unclear, but it's still quite easy. If you have our knowledge base beside, I've showed here. And this knowledge base gives you the idea what's behind the device command, what's happening, or what values do I have to move inside this command to perform which action. You see in the bottom line, you need to see all the data types needed. And so it's quite easy to do the programming. That just as a short introduction. If you want to have a deeper view how MotionCode does work and how the programming is done, there is a webinar also on this Thursday where we want to do some live demo and show you during the webinar how to program the MotionCode. So, and then one question, if we go more and more to the end, what features will become next? So in which direction we will develop MotionCode? So is it, will we go the direction of a graphical programming, or will it be built up to a full engineering suite? A full debugging, is that needed? Has to be introduced? Should there be pre-programmed function libraries? Should there be the possibility to execute motion codes parallel on the motor, so having 2 or 3 motion codes in parallel running on the motor, or completely something else? You see the question mark, that's more or less our idea. So we have a big bucket of arrows in which direction we can shoot this development. But I want to give the message, it's really up to you. So we're following here an agile setup, and we also following the inputs of our early adopter customers, of our pilot customers, where we should develop, or in which direction MotionCode should develop, and especially the environment. So use the chance, start programming with MotionCode, and also bring it in that direction you need it. Then short round in what does MotionCode and IoT, how does this work together? Which possibilities does this offer? And how the whole world of software development of in Dunkermotoren looks like. So you see here on the left side the same picture than before, but just added with this device cloud with an edge part. And that's also bricks in the puzzle where we developing and delivering software to connect motors to the cloud, to also connect motors to your local IT system, and also make a deeper integration there. Benefits of the combination of both is that it allows you to do a remote management of MotionCode, and also rollout of updates, bug fixing, and monitoring, condition monitoring of the MotionCode remotely, what's going on. You have a consistency from the field to the cloud. Everything is managed in the same menu. So we have a one-stop shop from controlling up to monitoring the motors. And think one point next to this is that we really have an openness here. We integrate in your environment. We don't bring hardware with us. It's also everything is available as a software, as Docker containers, and yeah, we set on open standards like MQTT, OPC Docker. So if you are interested more in this topic, rewatch the last webinar, New Horizons with IoT on YouTube. And yeah, that's just a short side note, what's possible also with mobile applications. So at the end, I can say if you want to become modular, use MotionCode and just start the programming. And remark, the 11th of October, there we will have a big announcement from Dunkermotoren side where also the direction of MotionCode and IoT goes to, and where the way will be. So therefore, we are close at the end. I see there is one question in the chat. So give me a second to read the question and then I will answer it. I think it's easy to answer this question. Yes, that's possible. So if the sensor is connected to the motor, it's possible to pass through this information from the sensor over the existing bus connectivity. Are there any further questions from your side? If not, then I just can show my contact data. Feel free to contact me via mail, via phone, if some question comes up later on. And then thank you very much for attending this webinar. And I also hope to see some of you in the follow-up and programming practice webinar on Thursday.